But before we dive in, I just wanted to do a quick intro about why we're all here. So just as a reminder, my name is Jared Yarnell Shane. I'm the Entrepreneurship Director at the Biomimicry Institute. And wanted to share about why we need to learn from nature to create a more sustainable, regenerative, and circular economy. So we all know that we need to find and adopt green, healthy solutions fast, but where do these solutions come from? For material and chemistry advances, it can take years to develop something new in a lab. And this is where biomimicry comes in. In nature, what we call strategies have evolved over the course of millennia that address everything from color to decomposition. And this is all done with life-friendly materials and chemistry. So why start from scratch when we can identify technology that already exists? So the lovely folks you see up here on this panel are entrepreneurs and scientists. They've learned from nature to create new products that enable and empower the circular economy. So we're going to dive in, and we're going to do this session a little bit differently. So we're going to allow each of these individuals to have about 3 minutes to present their work. And once they're all done, we'll have about 10 minutes left for some questions. So as they're presenting, post some questions in the chat. I'll note some of them down, and we'll have a nice kind of panel discussion. All right, so sound good, everyone? Deanne, we're going to start with you. Right. So Diana, I'm going to have to, I think, remove you from the stream for right now, and then we'll add you back in after Deanne's done.
I need the power to share my screen, Jared.
Yes, you should have it now, I think. Let's see. Still can't, can you?
On our way, on our way.
All right, all right. There it is.
Is it full screen? We're looking good?
Perfect.
All right.
Yeah, I'll maximize this. So without further ado, this is Deanne Charos. She's the co-founder and chief science officer of Werewolf.
Hi, everybody. I'm Deanne. Yeah, as Jared said, I'm a co-founder of Werewolf. We're a company creating biodegradable textile fibers with built-in color and performance. I think everyone has that favorite go-to piece of clothing. For me, it's this black jacket. It's super comfortable, it's waterproof, it's wicking, it's just a little bit stretchy. It's perfect for commuting to work on my bike and backpacking trips in the elements. And as much as I love it, there's just something really uncomfortable about this jacket. The properties that make me love it so much, the color, the waterproofing, the stretch, these features are currently provided by synthetic textiles, toxic dyes, and finishing agents. And they come from non-renewable sources with huge carbon footprints and also contribute to both microplastic and chemical water pollution globally. But the biggest impacts are also the biggest opportunities for innovation. And as usual, nature has the answers. All the performance, technical, aesthetic properties we want our clothes to have can be found in nature, but without the toxicity. Nature uses microscopic protein structures for performance and aesthetics. It's the shape of a protein that can dictate function. Stretch, waterproofing, even color. These are all properties that can be provided by the microscopic structure of a protein. For example, look at this amazing coral. Its hot pink color comes from a protein called RFP. We were really inspired by this amazing color, and as such, we created naturally fluorescent, bright pink fibers. A small tweak to the shape of the protein changes the color and gives us our green fibers. Werewolf designs proteins to have targeted properties and incorporates these proteins into textile fibers with a circular life cycle. To do this, we use microbes as our raw material factories to produce our colorful proteins. From there, we go from fluorescent protein to fluorescent fiber by using green chemistry to link the proteins into a functional textile fiber with a circular life cycle. Bringing Werewolf technology to market will offer brands and manufacturers independence from toxic chemicals, petrochemicals, dyes, and chemically intensive finishing products that are currently wreaking havoc on the earth. Werewolf fibers will help reduce a brand's water and carbon footprints with the entire product's life cycle in mind. As a team, our diverse expertise spans across fiber science, genetic engineering, and even material science, as well as fashion and business, giving us a holistic perspective of what it takes to get a fiber to market and how we as a company can help drive the fashion industry to a model of circularity. As our company grows, we see this as an expansive platform to follow nature's blueprints to create an array of biodegradable textile fibers with inherent properties like color and performance, stretch, moisture management, wicking, without the toxicity. A future where textile production does not have to be synonymous with environmental impact. Thank you so much for your time.
Awesome. Thank you, Theanne. Amazing. The work that you're doing with Werewolf here. If you have any questions for Theanne or Werewolf, put them in the chat and I'll make sure to note them down. So up next, Theanne, I'm going to bump you out so we can get Diane in here. Diana. Up next, we have Ryan Pearson, who's the co-founder and COO of Cypress Materials. So Ryan, when you're ready, go ahead. And right now we can see your notes slide, just so you know.
Okay. How about now?
We're still seeing your presenter view. Yeah.
Oh, that's going to be a problem. All right. Well, do you want to move on to the next person and I can try and fix this?
We can do that. Birgit, you ready to go?
Yep. Sounds good. I'll get my slides up.
All right. We're going to move ahead to Birgit then. And Birgit is the co-founder and CEO of Spotless Materials. We'll circle back to Ryan here after she's done. So yes, we can see you. If you click twice to maximize the slides, then you can all see it easier. Go ahead.
Okay. And can you see my full screen slides?
Yes, good to go.
Okay, great, awesome. All right, hi everyone, I'm Birgit, co-founder and CEO of Spotless Materials. And at Spotless Materials, we make easy to apply anti-fouling coatings for toilets, sinks, mirrors, and more. So in 5 minutes, customers can transform their fixtures into easy, clean, sustainable ones with the potential of reducing their water footprint by over 100 liters per day. So to reduce the water footprint in the average US home, you have to start with the bathroom. This is because the average home produces about 800 liters of wastewater each day. And the largest contributor here is the toilet. But what if you didn't need to flush the toilet or flush all that water? And what if the bathroom surfaces could just keep themselves clean? To create a self-cleaning bathroom, our team of scientists looked to nature for inspiration. Specifically, we look at the carnivorous pitcher plant. This plant has a slippery when wet rim, and when it's dry, insects are able to walk freely on the surface. But when wet, they slip and slide into the belly of this carnivorous plant. So inspired by the micro and nanoscale features of this plant, we created a liquid entrenched smooth surface. The way that works is we spray this coating onto a surface and it creates nano hairs. These bind to the surface and they serve as a sponge that holds onto a thin layer of liquid lubricant. The result is a super slippery surface that almost nothing can attach to. So, for example, on the left, we have a state-of-the-art hydrophobic glazed toilet, and on the right is a toilet coated with our coating. So instead of repelling ants like the plant, we're repelling synthetic waste. We're currently offering these coatings direct to consumer online with a number of business-to-business opportunities in the pipeline. The coating process is simple. You simply clean and dry the surface, spray our coating, and any residue can be rinsed or wiped away very easily. This process takes about 5 to 10 minutes. Our coatings stand out from other hydrophobic coating technologies in their ability to repel sticky substances. So in our tests, we've demonstrated that surfaces coated with our coating compared to glass or ceramic exhibit 99% less bacteria, 95% less mineral buildup, and 90% less solid waste. This allows for 90% less water consumption, and in home tests that we've conducted, 1 milliliter of our coating is able to save 1,000 liters of flush water. We officially launched our product last November, and we've sold across the US and in 28 countries. And we founded Spotless Materials to see our technology realize the impact that we know that it's capable of. We're also backed by leading investors and organizations that believe in the same thing. But bathrooms are only the beginning. Surface contamination spans industries, and surface cleaning leads to wasted water, cleaning chemicals, and money. So at Spotless Materials, we envision a more sustainable world made possible by anti-fouling surfaces. Thank you.
Thank you, Birgit.
Yeah,
Some great questions there. Thank you for sharing your work. Ryan, are you ready to go?
Yeah, let's give it a shot.
All righty. And please keep posting those questions over there for Birgit in the chat. And Ryan, when you're ready.
Okay, let's see if we can get this going. Are you seeing?
Yes.
The PowerPoint?
We sure are.
Great news. All right, let's go. My name is Ryan Pearson, and I'm the co-founder and COO of Cypress Materials, and I'm excited to tell you about how Cypress is reinventing color. As a society, we have progressed significantly in many technical aspects, from advanced sensors, reducing the cost of energy, to recycling. However, in many of these fields, the underlying unifier is that we use colorants in almost every field, and this crucial component is holding us back. Dark objects like cars are difficult for autonomous driving vehicles to see because the dark color doesn't reflect the signal that these devices rely on to map the world around them. And nearly 90% of all homes have dark surfaces, which heat up and ultimately have shorter lifespans than their white surface alternative and are chosen due to aesthetics. Large companies are shifting their focus to sustainability while still using colors like green, which cannot be recycled or composed of safely because it contaminates everything else. Broadly, color and coatings performance are limited by aesthetics, application, expense, range, and toxicity. To reinvent how humans interact with color, we took inspiration from nature. Unlike the blue from the pigments and dyes that surround us, the cypress butterfly gets its color from structural color. Their wings are covered in tiny scales that reflect a specific wavelength of light, which we perceive as blue. Using commercially available raw materials and Nobel Prize-winning chemistry, we can make materials that, when formulated and applied to a surface, will form nanostructured reflective coatings. Cypress is democratizing nature's sustainable structural color that doesn't require any pigments or dyes. With our paint, we are able to achieve deep, beautiful color or opalescent effects that can't be achieved through any other means. Similar to how nature has evolved to reflect different colors, we are able to tune our coatings to reflect ultraviolet, visible, and near-infrared light. In this clip, we demonstrate how Cypress Materials achieves sustainable color without any pigments or dyes. Our solids can be tuned to produce different colors during manufacturing or in formulation. And the materials are developed from raw feedstocks that can be found on your grocery store shelves and are common in the paint industry. While this demonstration allows you to see the visible reflective coatings that we can make, transparent, ultraviolet, and near-infrared reflective coatings can be formed in a similar fashion. You can apply our paint with a simple paintbrush and eliminate toxic pigments and dyes from consumer products like nail polish. These materials can be formulated into an aerosol can, opening up the possibility of a do-it-yourself application. In this first clip, we see a spray application take place on 3D objects similar to an automotive body. Next, we can see the spray application wherein our infrared or our heat reflective coating can be applied to rough and uneven surfaces. Imagine this application making building materials more energy efficient while maintaining the dark colors that consumers love. Since incorporation in 2019, we have already generated over 100,000 in sales and have signed a joint development agreement. We are currently in conversations with the world's biggest cosmetic suppliers to develop our structural color for nail polish. Our system enables the first customizable high chroma colors with only 2 components. Cypress is developing our materials for printing applications. Here, our sustainable color expands the printable space by 133% with our vibrant, eye-catching colors. Our reflective coatings can also expand the color palette while keeping cars cool and improve both the appearance and the performance. And lastly, our team is excited about developing our heat reflective coatings for buildings, where our infrared reflection materials can help keep buildings cool without imparting an aesthetic change. All of these markets are addressed with the exact same material. And because the color industry is so large and distributed, we have strategically positioned our go-to-market pathway so that the small volume opportunities could pull us down the cost curve and unlock these high volume applications. Our team is looking for ambitious first market adopters who are as excited about sustainability and reimagining the possibilities of color as we are. Thanks.
Thank you, Ryan. Thanks for sharing all the great work that you're doing. I'm gonna end your screen share here. And now, Diana, we're ready for you. So let's go ahead and bring up your slides. And while you're doing that, I'll intro you. Diana Youssef is the founder and CEO of Changewater Labs. All right. Oh, but you're on, we can't hear you right now, Diana.
Sorry about that. All right. Okay. All right, everyone.
Could you start your
I'm
slideshow? We still see the, oh, there it is.
Yeah.
Perfect.
You see it? Okay, great. Hi, everyone. I'm Diana Youssef, founder of Changewater Labs. Around the world, 50% of people, that's half of us, live with no access to a safe, and that's because they live in places with no sewage plumbing. When you can't flush, things get messy fast, and getting rid of unflushed sewage is costly. So Changewater Labs thinks everyone should have access to a safe, clean toilet. So we've invented a new way to flush away waste. We shrink it. We've invented a new way. Well, essentially, human waste is 95% water. Instead of flushing it, we evaporate it. We borrow our approach from nature, how plants pull water out of the soil using a process called evapotranspiration. Plants sweat, evaporating molecular water from their leaves through tiny pores called stomata. This evaporation, in turn, pulls water from the wet soil up through the roots. This movement of water is driven by humidity differences between the dry air above and the wet soil below. So Changewater has developed a membrane that essentially does the same thing, pulling molecular water out of human waste, driven by moisture differences between the wet waste on one side of the membrane and the dry air on the other side of the membrane. Using this this video demo shows how our membrane, which we call shrink wrap for crap, dehydrates and evaporates waste fast without external power or heat, converting 95% of it back into pure water vapor. Using this technology, we've developed the iThrone, a waste shrinking drop-in toilet that evaporates daily sewage on site. The iThrone uses bags of our membrane to collect and quickly vaporize waste, flushing away 95% of it without the need for external power or plumbing. The iThrone targets the growing need for safe sanitation in crowded urban slums and for drop-in sanitation in emergencies. By shrinking sewage volumes on site, the iThrone cuts collection costs in half while increasing toilet access and servicing efficiency. The cost for one communal toilet could now instead cover 4 of our iThrone toilets. Instead of each collector servicing a small number of container toilets daily, they could service 20 times more of our iThrones monthly. The iThrone cleans up communities and delivers cross-cutting social and environmental impact. Not only does our toilet reduce water use and pollution, it actually converts waste back into clean water. By quickly dehydrating waste, our toilet cuts off methane emissions from wet waste and cuts down on waste collection, reducing fuel use. Our team believes that safe sanitation is a basic human right. And with these bio-inspired strategies to clean up and eliminate waste, we aim to make safe sanitation available to everyone, everywhere. Thank you.
Awesome. Thank you, Dan. Deanne and Ryan, why don't we have you come back in and join? And please keep sending in those questions. Here's Deanne. And here is Ryan. So wanted to ask, we have about 6 minutes left. You all have a PhD, you're all scientists. So can you talk about where you first got your inspiration? And if you could do it real quickly, that would be great. Let's start with you, Diana.
I was actually working with NASA to look at how to recycle wastewater on the space station. And so, it sort of triggered a thought in my head that, if you could do this in the ultimate of off-grid locations in space, you could do this for poor communities on Earth. And I, as a bioscientist, always look at how nature does things, and knowing that every plant on Earth figures out a way to evaporate water and that waste is mostly water, I figured, let's see if we could recreate this way that plants evaporate water, and thereby we could shrink waste.
Awesome. How about you, Thienne? Oh no, I think
Can you hear
I
me?
think we lost your audio there. Yeah, try
Can you
it.
hear
Try
me?
again. Yep.
Yeah, so I mean, I grew up kind of in the inner city in New York, a Greek child of Greek immigrants, and I always sought out nature. I mean, we had these little cement blocks, and I was always really, really fascinated by it. And then when I moved on to science, I actually started doing work with artificial photosynthesis, so circular systems. So biomimicry was, I really wanted to address the pollution and the environmental issues, and I thought, okay, clean energy was the way to go. And my original work was in splitting water with sunlight to create hydrogen as an energy carrier and then using it in fuel cells. And then when I took a faculty position at FIT and I was kind of exposed to the toxicity of the fashion industry, it seemed like that was just such a huge opportunity to make a big difference and to apply the work I'd done in self-assembling molecules for energy applications for sunlight to materials, right? I mean, if you can make molecules assemble, you can make them assemble. So I got really fascinated by biomaterials and looking to how nature builds materials from the bottom up and builds in color and builds in performance non-toxically. And from there, I kind of started working with AlgaeNet, where we developed it. I'm a co-founder and was formerly the director of the science program there. And then I just went down the rabbit hole of biomimicry for material impacts.
Awesome. Thanks, Deanne. And Birgit and Ryan, could you quickly just share your background?
Sure. Yeah. So for me, I've always been personally interested in, people and science. So for me, grad school was all about learning how to make things that help people, broadly speaking, help people, learning how to make technologies. And then in grad school, I became dissatisfied with it just ending at the technology. I wanted to learn how to actually bring it to market, bring it to the public space. So that's sort of why I ended up I've always been fascinated with with nature itself. I was in a bio-inspired engineering lab in grad school, so all tied together. Now I'm bringing this technology that we developed in grad school to market. So that's sort of my path there.
Cool, thanks.
I got lucky to have a advisor in grad school that was very supportive of going down the path of green chemistry. So in the first summer, I went to the American Chemical Society, or ACS, Green Summer School, which I think is a full paid for experience that whether an engineer or chemist, and kind of from there went to other chemical and engineering conferences throughout grad school. So yeah, that really kind of got it started and be able to network in that field.
Awesome. Thanks, Ryan. A question for you and Birgit, since I think you two have some of your products are already on market or you're already starting to make sales. Can you tell us about kind of some of the challenges and difficulties that it took to get to that point?
Sure. Yeah, I can talk about that. Yeah.
Lots of cold calls.
Yeah. Lots of.
Yeah.
You go ahead, Brian. I'll go after you.
We kind of got lucky with COVID in a way, in that I had all these messages out to people to try and hey, this product would really work with your line, and no one was responding. And when everything shut down, people were ready to hop on the phone, connect with humans. So lots of cold calling, and just kind of after amassing conversations, people really kind of saw the change. And I think more recently we posted a lot of videos on our material to show this is real. And I think once we were able to generate some of that excitement, that's when we started getting even more calls back.
Yeah. For me, the biggest challenge or I guess the biggest insight that came from the biggest challenge was learning how to convince people that they needed something, and understanding that they didn't, customers don't always understand the technology, they understand a product. So learning how to just talk to people and then make guesses and then iterate on those guesses to make new products, to say, this is what you want. Is it what you want? I think this is what you want. That's often more effective than just saying, here, I have this technology. It works. It does this. It's much more effective showing people a thing in a bottle and then telling them what it does. I guess that was challenge number one. Challenge number two is it's always figuring out different problems all the time and calling people, and lots of asking questions.
Yeah, no, thank you. Well, we're almost at time, and I just want to make sure we honor the time and give a big thanks to all of you for the work that you're doing. If you wouldn't mind, if you feel comfortable, if you could drop your LinkedIn profile maybe in the chat, That way people can continue to follow up, because we want to keep some of these amazing questions and conversations going. So thank you. You're painting the future. You're showing us a way that we can make materials that are green, sustainable, and regenerative for our Earth. So thank you.
Thank you.
For sharing your
Thank
work
you.
and stories.
Thank you.
Great.
Thanks all.
Thanks, everyone.
See you soon.
Do we just hang out for 5 minutes, or
I guess, yeah, that's,
an extended goodbye?
well, yeah, we'll see when we get cut off, but I saw that there were a number of questions, I think, Diana, for you around bacteria, and then the end
Yeah.
follow up for you around other applications. So Diana, we'll start with you.
Oh, okay. So essentially, while we don't target sort of complete sterilization, by rapidly dehydrating waste, you're depriving bacteria of water, and then you actually do end up killing a lot of the bacteria. So, but really the first thing that we were trying to do was do volume minimization, which is a critical component of both reducing the cost of the logistics of the waste, as well as keeping it contained in cramped spaces. So in future iterations, we'll be looking to, we actually do have a technology that we are developing, which is using, which is actually starting to kill the bacteria. We're essentially using some of the waste products in the toilet as a way to sterilize the waste, but the waste on the other side of the toilet. But we are, but that's sort of figuring that part out is going to be a part of the sort of future development, and that's one of the things that happens with startups. You end up, you go after what's the immediate need, and then you evolve it to sort of, have more bells and whistles. But the immediate need was getting rid of the waste and keeping it contained.
Got it. Fascinating, Diana. At the end, we had some questions for you. Like, could your technology at Werewolf be used for paint or like other applications, or is it textile and fibers only?
We are focusing on textiles and fibers because of the huge impacts of the fashion industry on biodiversity. We celebrate these organisms and kind of use them to help protect them. There are many applications. We're still in the really early stages, so being able to put functional performance and aesthetics into a material, this approach does have the potential to be really expansive and reach other markets, but our particular focus is on the textile industry, largely because so many of the big impacts are there. So that's where we're starting, but we do see it as an expansive platform for kind of rethinking materials and where we get the functional and aesthetic properties from.
Awesome. Cool. Well, I know we're continuing to go over time here, but we're not getting kicked out yet. So, Birgit, so we also had some questions for you about, are there any industrial applications? Do you want to talk about that?
Yeah, absolutely. So one of the challenges, I guess another challenge that we've had as a company is understanding that we have a platform technology. It's an anti-fouling technology. It can be used in all sorts of applications. Half of the investors we talked to said, focus, and others are like, no, you have so many opportunities. So we've decided to do a little bit of both. So we are, we did decide to go into sanitation because that's where we got started. We started working with a group sponsored by the Reinvent the Toilet Challenge for the Gates Foundation. And that's our story. It's a great story to tell, and so we're commercializing there. But there are plenty of applications as well. We do have a contract with the Office of Naval Research for some naval applications. We have some interest from the automotive industry. We're working on a contract there. So there are others that are time to market for these business-to-business types of applications or manufacturing applications are in the order of 2 to 4 years. So we're nurturing those, planting those seeds while we're commercializing, trying to get to cash,
Awesome.
positive and profitable with consumer sales.
Awesome. Thanks, Birgit. Looks like we're going to get kicked out here in about 30 seconds. Ryan, real quick. Do you have is your paint food safe?
I wouldn't eat the paint.
Okay.
But yeah, I'd be happy to talk about that. I just threw up my LinkedIn link, and we can discuss kind of what that application would look like.
Awesome. Well, we'll end it there. So I think you can see there's a whole range of applications, and please connect and follow up. We're excited to chat with you all. All right. Bye, everyone.
Bye.
Final
Thank
goodbye.
you.
Thank you, Jared. Thank you, everyone.